In this video of ParetoWin, we will show you how you can upload a model and apply different boundary conditions. Under the geometry menu, observe that we are in the meter, Newton, second units. Now click on Load STL. Currently, ParetoWin only supports import of STL files. Future versions of ParetoWin will support other formats as well. Once you click ParetoWin, you'll open up a folder, and this folder is underneath the ParetoWin desktop folder. And if you look under the examples, you'll see various models, and one of the models that we'll be interested in is the 3-hole bracket. And observe that the 3-hole bracket is really an STL file, and as opposed to the 3-hole project, which we'll talk about later on. Now click on this and open the file, and this will bring up the 3-hole bracket model. And various information about this model is displayed here. For example, this model has about 450 triangles, and the maximum length of this part is around 0.1 meters and so on. For the material, we'll choose a Ti6Al, and we apply the material, and that's reflected here. The next step is to apply the boundary conditions. We're going to restrain these two faces. To do that, we click the first face, and then by holding the control key, while holding the control key, we select the second face. For the boundary condition type, since we are restraining in all three directions, we can use the XYZ fixed condition, and we apply. And these black arrows in all three directions indicate that this face is restrained in all three directions. The next step is to apply a load. We select this hole here, and we're going to apply a vertical force, which is the Y direction. We can apply a force of negative 5,000 newtons to this face, and that's indicated as shown. As before, we can now carry out a finite element analysis with the standard number of elements, and that will be carried out in a couple of seconds. Once FE is complete, we can now start with topology optimization. Here we're going to consider a couple of options. We're going to keep these options as it is. For example, we're going to have a target volume fraction of 0.5. We'll play around with this in the next video. For now, we're going to say keep the fixed faces. What this indicates is that we want to retain the material around these two holes for restraining those two cylindrical faces. So that's what this option indicates. The next option is the symmetry. If you recall, the thickness direction was a Z direction, and we want to maintain symmetry during topology optimization along this direction. And we select the Z symmetry, and we are optimized. The optimization progress is reported here, and the optimization should be completed in a few seconds. Once the optimization is complete, you can, as before, save the STL or look at the various STL results, isosurfaces that are obtained during topology optimization. What we're going to do now is save the work. We have applied various materials and boundary conditions, and we want to save this as a project. So we click on Save Project, and a file is automatically saved in the download folder. In the next video, we'll learn how this project file can be used for further analysis.